Public blockchains require total public visibility to remain decentralized and trustless. Every transaction must be observable by every participant. However, this level of exposure creates a specific conflict with how financial markets operate. Before a transaction is finalized on the ledger, it is broadcast to the mempool. The mempool is a public database where pending transactions wait to be included in a block by a validator. While these transactions sit in the mempool, automated programs called searcher bots scan the data. They are looking for specific, high-value trades that they can use to their advantage. In an MEV sandwich attack, a bot identifies a pending trade, placing its own buy order immediately before and a sell order after. This manipulates the price, forcing the user to pay more. The price difference, the slippage, is captured by the bot as profit. This exposure prevents larger organizations from moving to the blockchain. Corporations cannot manage payroll or execute buybacks if competitors can see and exploit the details of those transactions before they are even processed. The Fairblock network addresses this by introducing pre-execution privacy. The goal is to hide the transaction data until the moment it is actually processed on the chain. This starts with the Fairblock Software Development Kit, or SDK, a collection of software tools that allows developers to integrate encryption directly into an application. When a user initiates a trade, the SDK encrypts the transaction content using a master public key. Once encrypted, the data enters the public mempool as an unreadable blob. To any outside observer, the specific details of the trade are completely obscured. Because the payload is unreadable, MEV bots cannot calculate how to exploit the trade. This allows the transaction to be safely sequenced and included in a block without being front-run by automated searchers. By securing the transaction content until its position in a block is fixed, the network removes the information advantage that bot operators rely on. The process of revealing that data is handled by FairyRing. This is an application-specific blockchain that manages the decentralized generation of the data needed to reveal the transactions. FairyRing utilizes threshold identity-based encryption, or TIBE. In this system, information like a specific block height can serve as a public key. Independent validator nodes each generate a distinct mathematical fragment of the necessary decryption data. A single node cannot reveal the transaction on its own. A specific numerical threshold of these fragments must be combined to produce the final result required for decryption. This combined data is then sent to the destination blockchain. It allows the user's transaction to be read and processed at the exact moment of execution. Since no single party ever holds the ability to reveal the data prematurely, the network maintains privacy while keeping the process decentralized and secure. This modular structure allows Fairblock to provide services to ecosystems like Ethereum and Arbitrum. This enables a new category of confidential applications, or CApps. One application of this is Stabletrust, which provides a framework for managing stablecoin transfers, where the transaction details remain hidden. This ledger shows how Stabletrust operates. The numeric values and account balances are obscured, which protects sensitive data like employee salaries or corporate trade sizes from public view. The wallet addresses remain visible, ensuring the ledger is traceable. This allows the system to remain compatible with regulatory frameworks like MiCA in Europe or OFAC requirements, as specific data can be revealed to authorized auditors if necessary. Another application is Fairates, which applies this technology to the lending markets using sealed bid auctions. In most bidding systems, participants can see what others are offering in real time, which often leads to manipulation. In Fairates, every user submits their bid in an encrypted state. Once the deadline is reached, FairyRing facilitates the simultaneous revelation of every bid. A single clearing price is then calculated mathematically, ensuring a fair outcome. By securing data in the present and only revealing it once an order is confirmed, the blockchain becomes a viable environment for professional finance. Encryption and transparency are no longer in conflict. They become the tools required for a fair on-chain economy.